So in this video, proof by induction number 3, we're going to look at divisibility again. An interesting word, short enough word that has 5 I's in it. Completely irrelevant, but an interesting fact. Let's look. N is equal to 1. 3 to the power 2 times 1 minus 1 is 3 squared minus 1, which is equal to 8, which is divisible by 8. N is equal to k. We have 3 to the power 2k minus 1. And we're going to assume that that's equal to 8 times the number. I could bring the 1 across, but I don't think I need to. So n is equal to k plus 1. We have to show that 3 to the power 2 times k plus 1 minus 1 is divisible by 8. So 3 to the power 2k plus 2 minus 1, which is 3 to the power 2k by 3 to the power 2, and I still have my minus 1. So this is 9 by 3 to the power 2k minus 1. So always think of your number. We want an 8. So in this 9, I have an 8 plus 1, which should bring me back to my assumption by 3 to the power 2k. I have my minus 1. So this is 8 times 3 to the power 2k plus 1 times 3 to the power 2k minus 1. And we said that this was 8a. So I can say that that's 8 by 3 to the power 2k plus 8a, which is 8 times, sorry, I have my small 3 here, 8 times 3 to the power 2k, which is 8 times 3 to the power 2k plus 8, which is divisible by 8. Therefore, true for proposition k plus 1. Shown true for proposition 1. Assume true for proposition k. Therefore, true for all values where n is an element of natural numbers. So learn this off. There is marks for this at the end of the question, which seems crazy, but that's proof by induction. Let's look at another couple of questions. So is 7 to the power 2n plus 1 plus 1 divisible by 8 for all n is an element of natural numbers? Let's check proposition 1, or n is equal to 1. 7 to the power 2 times 1 plus 1 plus 1, which is 7 to the power of 3 plus 1. 7 to the power 3 is 343. 749s plus 1, which is 344. You'll use a calculator, but just dividing in, we're going to get 43. So divisible by 8. So yes. We're going to assume proposition k is true. So we're going to get 7 to the power 2k. Put our k in, so we're going to get 7 to the power of 2 times k plus 1, just so we can see it. So we're going to say that that's equal to 8 times the number. So we're going to want to see that 7 to the power 2k plus 1 appear again. Proposition k plus 1. 7 to the power of 2 times k plus 1 plus 1. Did I leave out my plus 1 at the end? I did here. You can see plus 1 plus 1. So this is 7 to the power 2k plus 2 plus 1, which is 7 to the power 2k plus 3 plus 1. Keep in mind the assumption, 7 to the power 2k plus 1. So this is 7 to the power 2k by 7 to the power 3 plus 1. So if we keep in mind our assumption here, we want 7 to the power 2k plus 1. So this has to be 7 to the power 2k by 7 to the power 1. So that leaves 7 to the power 2. And we have this plus 1. So we have this guy, 7 to the power 2k plus 1. Sorry, 7 to the power 2k plus 1. Now what is 7 squared? It's 49. What number do we want? We want an 8. So 6 8s are 48. So this is 48 plus 1 by 7 to the power of 2k plus 1, and then this plus 1 is here. So this is going to give me 48 times 7 to the power of 2k plus 1 plus 1 times 7 to the power of 2k plus 1, and then I have my plus 1. Hopefully this was my assumption, 7 to the power of 2k plus 1. You can see it was equal to 8a. So we have this guy is 8a. This guy is 6/8 or 48. So this is 6. This is, I'll just write it as 40. I'll do it in 2 steps. 48 by 7 to the power of 2k plus 1 plus 8a. To show it's divisible by 8, I'm going to factor 8 out of both of them. So that's going to be 8 times 6, 8 or 48. So 7 to the power of 2k plus 1 by my 6, and then plus 8, which is divisible by 8 because we're making 8 a factor. Therefore, proposition k plus 1 is true, and so on until you get full marks. So we'll do one more of these questions, and then hopefully you've mastered divisibility proofs. So they look a bit trickier. Just follow the same process and we'll see where we get to. So we're looking here, is 5 to the power of 2n plus 12 to the power of n minus 1 divisible by 13. When n is equal to 1, we get 5 to the power of 2, 2 ones, plus 12 to the power of 1 minus 1, which is 12 to the power of 0. And you know that anything to the power of 0 is equal to 1. So this gives us 26, which is divisible by 13. So yes, n is equal to k. We get 5 to the power of 2k plus 12 to the power of k minus 1. This is my assumption. We're going to need to come back to it. N is equal to k plus 1. So we have to show that 5 by 2 to the power of k plus 1 plus 12 to the power of k plus 1. So that's replacing the k, and I have my minus 1. So I'm going to get 5 to the power of 2k plus 2 plus 12 to the power of k. So going from here, if we look at my assumption, let me do the 5 to the power of 2k first, just splitting that up. 5 to the power of 2k times 5 to the power of 2. Now, the 12 to the power of k that I have here, I want 12 to the power of k minus 1. So how would I make this stay as 12 to the power of k? I'd have to multiply it by, stay as 12 to the power of k, but make a k to the power of 12 to the power of k minus 1. So what would I have to multiply 12 to the power of k minus 1 by to get 12 to the power of k? Just 12 to the power of 1. So this guy is the same as this guy, so I haven't changed this value. So that should help me now with my assumption. So I have, now we want it divisible by 13. So we know that we're going to have to get a 13 in here. So I have 5 squared, so I'm going to write 25 by 5 to the power of 2k plus 12 to the power of k minus 1 by 12 to the power of 1. How can I get my 13 in here? It's going to have to be 13 plus 12 by 5 to the power of 2k plus 12 to the power of k minus 1 by 12 to the power of 1. So multiplying this out, I get 13 by 5 to the power of 2k plus 12 times 5 to the power of 2k plus 12 to the power of k minus 1 times 12. So what can I do here? I want to get back to my assumption, which is 5 to the power of 2k, and we can say that that's going to be equal to 13 times a number. So let's see where I can get that from. So if I factor out my 12 from these guys, if I take 12 outside, I'm going to have 5 to the power of 2k plus 12 to the power of k minus 1, which you can see 5 to the power of 2k plus 12 to the power of k minus 1 is my 13a. So that's 12 times 13 times a number, which is also 13 times the number times 12. And I also have 13 by 5 to the power of 2k. So if I factor out my 13, I've got 13 outside, and inside I have 5 to the power of 2k plus 12a, which is divisible by 13, as 13 is a factor of it. Therefore, true for n is equal to k plus 1, and continue on and state that it's true for everything else. And that's the end of proof by divisibility.